Okay. Page 5, section 5, we're actually looking directly at the square root and the cube root function. So we're only looking at squares and cubes now. But why? What does this have to do with the first 4 section? Do you think about why? Like when the author wrote the book, they decided to put this section right after we just talked about inverse, right after we talked about what a function is. Why? They're inverses of quadratic and inverse of polynomial, right? A big chunk of what we did in polynomial, even polynomial can go up to as many degrees as you want. You really look at 2 of them. One is even power, which is usually squared, and one is odd power, which is usually cubed. Anything beyond that gets a little too complicated, right? So the reason why in 3.5 they're introducing radical function now is because you just spend a whole chapter on 2 on polynomial, whole chapter on 1 on quadratic, and they tell you what inverse is, and now you know how inverse and the original function relate. This is automatic next step. Everything you learn about quadratic, everything you learn about polynomial, now applies to radical. Instead of having this thing that looked kind of daunting, you realize that, oh, we're just actually still doing quadratic and third degree polynomial. Just look a little bit different because now we kind of have to force ourselves to graph sideways. Okay? So notice that the square root of x, which is the parent function of a square root function, look exactly like the inverse of quadratic function, which is x squared. However, to keep this as a function, we ignore the negative part, and we only look at the positive side. And the nice thing about the radical being only positive is that we don't even have to identify that x has to be positive. Okay, are we all together? That statement makes sense? How are we doing so far? Thumbs up, you're still with me. Sideways, down, I already lost you. Okay, everyone? Connie has all 10 fingers down. Okay, sideways, that's fine. And this one is the parent function of x cubed. Again, turn sideways. Okay. What you want to do right now, whenever they talk about parent function, is that they want you to every time see square root of x, you immediately see this kind of random line that curves to the right. Whenever you see a cube root of x, you immediately see this s, but instead of now going up and down, it's now going sideways. Okay? That's what they want you to be able to do. So, I didn't block it. I don't know why I didn't block it. Let's block it. So, they want you to graph 1/2 square root of x. So immediately, in your head, you should automatically see this. 0, 0, 1, 1, 4, 2. Okay? Because at this point, with all that we've done in chapter 1, chapter 2, you can picture this without actually plotting points. Right? That's a graph of x squared. So you go to 1, 1, 2, 4, 3, 9, 4, 16. So now you do the opposite. You do 1, 1, 2, 4, which is really 4, 2. And then really the next one would be 5, 6, 7, 8, 9, 9, 3 would be your next point. Very good? Parent function. That's the easy part. And then that 1/2 means that it's a vertical shrink. And you're done. compare a graph with the original parent function, you would say it's a vertical strength by a scale of 1/2. How are we doing? Thumbs up. Sideway, down. Good. Everyone got that one? Okay, I'll go and just show this one. So this is the parent function, so you should be able to picture that as well. And it's a vertical flip and a vertical stretch by 3. So you flip it first, which give you that, and then you do multiply everything by 3, which give you that. On the test, I'm going to expect the same thing. I'm not going to ask you to plot the points. I want you to be able to give a general shape of the graph. Okay, questions on example 2. One more before we do some examples. This is an example from the using a graphing calculator. So again, this is a natural law. This is always true. The period of a pendulum is the time the pendulum takes to complete one back and forth swing. So it goes to the left, right, ding, ding, and that time is dependent on how long the string is. Did you guys know that? It doesn't matter how far you swing it. So if you're sitting on the swing in the middle elementary school playground, you can swing very high up, but the time for you to go from one end to the other end and back, assuming you're not like kicking it, time is exactly the same as a little kid that just goes like this. You're just going a lot faster, but the time period to go from one end back to the same end is the same amount of time. That time is based on only one variable, which is the length. It's not even based on the weight on the bottom. And that's how, in the old days, the clock worked by having a pendulum that bounced on the side, on the bottom. You just measure the length, and you just have to let it swing. So, actually, it does depend on the weight. The weight is included in that decimal, but the time is the same. So putting in a graphing calculator, then you can plug it in and get to the point. Not too exciting. Just an example how you actually use radical functions in real life. Let's try some examples. Let's graph to an even one and an odd one. Let's do an even one, square, and a cube one.